Okay, so this is question 7. Graham paid $380 at the end of each month for 4 years to pay back a loan he borrowed for a car at an APR of 7.28%. How much did he borrow? Okay, so what we're going to write down is the formula. A equals PI by 1 plus I to the power of T all over 1 plus I to the power of T minus 1. Now, what we're going to do here is we're going to figure out what each value is. Now, the T value is 4 years. Okay, so 4 years multiplied by 12 months per year is 48 months. Okay, so T equals 48. Now, our 1 plus I value is going to be our B value in the calculator, and 1 plus I to the power of 12 has to be the same as 1.0728, because it has to be the same as that over 1 year. So we're going to do the 12th root of 1.0708 or 1.0728. So we do the 12th root. So shift 12th root of 1.0728, and we get 1.00587. Okay, so shift star B. Okay, so that's my B value. Now my C value is the I value on its own, and C equals, when I bring the 1 over to your side, it's going to be B minus 1. So I'm just going to put B minus 1 into the calculator, take away 1 to get your C value, and so we're going to shift star C value. Okay, now that that's done, we're going to find out what exactly we do. Okay, so the A value is how much you repay every week. So the A value is 380. The whole question is how much did he borrow. We're looking for the P value, so it's going to be P multiplied by, so we're just isolating out the P. Now I, as we said before, is the C value, so it's going to be C multiplied by B to the power of T, which is 48, all over B to the power of 48 minus 1. So we put this into the calculator. So what we're going to get is alpha C, then B to the power of 48 all over B to the power of 48 minus 1, and it's going to be 0.0239. okay, so P times 0.0239. okay, I'm going to keep the decimal places saved on the calculator as well. So then we know that P is going to be 380 divided by my answer from the last part, 0.0239. So 380 divided by that number, divided by my answer. Now what we find out, it's 15,845.18. So it's going to be 15,845.18. Okay, that's our answer to that question. So now we're on question 8. Okay, on question 8, what we have here is going to be Dorian paid $400 at the end of each month for 6.5 years. Okay, so it's going to be 12 multiplied by 6.5, and 12 multiplied by 6.5 happens to be 78. So this is 78 months. Okay, and we're going to write down our formula. A equals P multiplied by I, 1 plus I to the power of T all over 1 plus I power T, and then 1 plus I to the power of T minus 1. Please remember these are monthlies. Okay, so what we have to figure out is what is our 1 plus I value. Now we're doing it per month, which means that 1 plus I compounded 12 times has to be equal to the yearly rate of 1.062. What we're going to do next is we're going to find out what 1 plus I is. We're going to save it as B in our calculator. which is going to be the 12th root of 1.062. So it's going to be shift, just putting here, so it's going to be the 12th root of 1.062, and we get is 1.005. Okay, so 1.005. So it's shift star B. Okay, so that's the answer in B. Okay, I'm going to take away 1 to find the C value. Shift star C. Okay, so C equals B minus 1, which is in the calculator as well, okay, which is equal to the I value. Now we got to put in our values. We know that A is 400. Once again, we're going to isolate out P, so P is going to be outside here. Our I value is C, our 1 plus I value is B, our T value is 78, all over B to the power 78 minus 1. So 400 equals P multiplied by, so we just figure this out in the calculator. So it's going to be alpha C bracket B to the power 78, then it's going to be B 78 minus 1, and then what we get here is 0.01553. So P times 0.01553. We're going to divide that by 0.01553 over the other side. So it's going to be 400 divided by our answer. Gives us P. So 400 divided by answer equals 25,758.70. 25,758.70. Okay, and that's our amount of money there. Now, we're on to question 9. A loan of P is drawn over 2 years at the rate of I% per annum. An amount €8 is repaid annually. Find the present value at the start of the loan of the repayment made at the end of year 1. Okay, so our final value is always equal to the present value. Now it's usually P into 1 plus I times T. Okay, but we got to understand that P in this case is actually what we pay at the end of the year. So we actually pay, our present value is P. So we're just going to give that a different letter this time. I'm going to give it the letter M. M represents our present value. Okay, and in this case, our F value is going to be A. Now, our present value therefore equals A over 1 plus I times T. Okay, so at the end of the first year, it's going to be A over 1 plus I. Okay, at the end of the second year, so that's part 1 done. At the end of the second year, so for part 2, it's going to be A over 1 plus I to the power 2. Okay, and then part 3 it says write the sum of all present values of the payment made from year 1 to the final year. I don't know what the final year is, so let's call it year T, equal the amount of the loan draws down P. Use this information to find an expression for P in terms of A, I and T. So it has to like the amount of the loan drawn over the year has to be equal to the repayments. Okay, so P therefore would be equal to A over 1 plus I. Oh, sorry, so the entire amount of the loan will be equal to all the repayments. Okay, so it's going to be P equals 1 plus A over 1 plus I, A over 1 plus I squared for year 2, plus dot 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 A over 1 plus I to the power T. Now, use the sum of a geometric series to show this. Okay, so what I want me to show is use S of n equals small a. Small a is the first term, 1 minus Rn all over 1 minus R. Now, in this case, our starting off value, which is a, equals a over 1 plus I. We can see it's a geometric series. Every single time you're multiplying by 1 over 1 plus I. That's our R value. R value is 1 over 1 plus I. Now we're going to find out what Sn is. So to do Sn is going to be the same thing as P. So P ends up to be equal to A over 1 plus I, bracket 1 minus R, which is going to be 1 over 1 plus I to the power of n. And then on the bottom, we're going to have 1 minus R, which is 1 minus 1 over 1 plus I. Now, here's what we're going to do starting off. We're going to realize that this part here, okay, that part there is going to be 1 over 1 plus I. Now I can spread the power of n top and bottom. Okay, that's a rule of indices. Now 1 to the power of the n is still 1, and that's going to be 1 plus I to the power of n. I'm then going to adjust this here. I'm going to give them the same denominator. So 1 is the same thing as 1 plus I divided by 1 plus I. Plus I divided by 1 plus I. Okay, so what we're going to have here is P equals A into 1 plus I multiply by 1 minus what's it going to be, 1 over 1 plus I to the power of n. Now once again, I'm going to modify the 1 to make sure it has the same denominator. So to make sure it has the same denominator, I'm going to change the 1 into 1 plus I to the power of n divided by 1 plus I to the power of n. Now they have the same denominator. Okay, and then this is all going to be over. Now 1 minus 1 is 0, so it's going to be I over 1 plus I. Now remember, when you're dividing by fractions, you can move the fraction to the top and turn it upside down. So it's going to be 1 plus I all over I. So when I turn that fraction upside down and send it up, so what we're going to get is basically the 1 plus i's will cancel. This one gets multiplied by this one over here. And then we're going to equal P equals A over I. And then in here, we're going to have 1 plus I to the power of n minus 1 all over 1 plus I to the power of n. Now we're going to cross multiply the bottom. So we want A on its own, so I'm going to cross multiply this section up here. Okay, so when I do that, what's going to happen is it's going to be P I and then multiply by 1 plus I to the power of n, and then we're going to multiply down this part here, goes underneath the P, so it's going to be divided by 1 plus I to the power of n minus 1, and all that equals A, and that's what we're asked to prove. Okay, so that's question 7, 8 and 9 done.